Hello friends, let us now learn some important points about the metal or ceramic X-ray tubes. So in the last class we have learned about different types of X-ray tubes. So we have learned about the normal X-ray tubes, then we have learned about rotating anode X-ray tube, stationary anode X-ray tube, and then we have learned about the grid controlled X-ray tubes. Now let us learn about ceramic or metal X-ray tube. So this ceramic or metal X-ray tube is actually introduced by Philips Medical System, and the trade name for this ceramic or metal controlled X-ray tube is ceramic superrollatrix ceramic superrollatrix tube. So actually in the last previous types of X-ray tubes, we have seen that the X-ray tube is actually made up of glass, right? The X-ray tube is made up of glass. But here in ceramic or metal X-ray tube, as the name says, instead of glass, it is made up of metal casing. Okay, one change is instead of glass, there is metal casing. Number two, there are insulators which are produced. There are three ceramic insulators are present. These insulators will prevent the heat or electrons to flow from the anode or cathode to the tube casings. So that is ceramic insulators. So these ceramic insulators, three ceramic insulators are produced, that are present. That is the second change. And the third change is the anode. The anode is at the center. This anode has an anode shaft. Okay, this anode rotates on an axle. So this is anode disc. This anode will rotate on an axle, and at each end the axle has the ball bearings. So these are ball bearings. These are also ball bearings. So the anode is suspended on an anode shaft, which with the ball bearings on either side. So this anode is very massive, that is around 2000 grams in size. Whereas in normal conventional X-ray tube, the anodes are not more than 700 grams, whereas the anode in the ceramic X-ray tube is more, that is around 2000 grams in weight. Okay, then the main important use of the ceramic X-ray ceramic insulators. There are ceramic insulators. So these ceramic insulators are placed on either sides on anode and cathode. So this is one ceramic insulator placed at the anode shaft, between anode shaft and the metal container, metal casing, whereas it is also present at the cathode and the metal casing, and also the ceramic insulator is also present at the, so this is ceramic insulator which is placed at the anode. This is actually static winding, not ceramic insulator. Static rotor we have already seen in a rotating anode, right? This is the same assembly, but it is in a different uh, appearance. Okay, so this is ceramic insulator. So the ceramic insulators are actually three. This is first ceramic insulator, second and third. They will Their use is to insulate high voltage parts of the X-ray tube. High voltage parts of X-ray tube are nothing but the anode and cathode from the metal tube envelope. That is, this anode shaft is heated, similarly cathode is heated. Our aim is to prevent this heat from the cathode to reach the metal casing. So as a result, this heat will not reach the metal casing because there is ceramic insulator present here, which prevents the dissipation of heat from the cathode to the, it will prevent the transfer of heat from the cathode to the metal casing. Similarly, here the ceramic insulator will prevent the transfer of heat from the anode shaft to the metal container. Okay, so this also has three uses. One, it will prevent the off focus radiation. It will prevent, or it will decrease the less off focus radiation. We will see what this off focus radiation now, and it will increase the tube half-life. Tube half-life is increased, and also increase the tube loading. Tube loading is also increased. So let us see. So the main uses are to attach the high voltage transmission lines to the overhead supporting tower, and when we use metal as X-ray tube enclosure, there is less off-focus radiation, higher tube loading, and longer tube half-life. So let us learn about each of them in detail. First, less off-focus radiation. So what is off-focus radiation? See, the cathode, electrons from the cathode, they are accelerated towards the anode and they hit the anode. This occurs normally. Sometimes when the electrons from the anode are reflected back and they might hit the metal container, or some of the electrons from the cathode might hit the metal X-ray tube. So in that case, the metal is again, what is metal? Metal is a metal. It is again, it is made up of some type of lead or some metal. So this metal again produces X-rays. The X-rays produced at this point by this metal will go in different directions. Okay, but these X-rays which are produced by this metal is called as off-focus radiation, and the electrons which are deflected back from the anode or from the cathode, and they are not in the path of the electrons. The electrons have to go in this path. If any of the electrons are not in this path and they wander around in the metal X-ray tube, they are called as scatter X-rays or off-focus X-rays. Sorry, scattered electrons or off-focus electrons. So these electrons are called as off-focus electrons, and the X-rays produced from these off-focus electrons are called as scatter radiation or off-focus radiation. So these scatter radiation or off-focus radiation are decreased by using collimators or lead diaphragms, which we will learn in our upcoming classes. So this is the main thing. So ceramic or metal X-ray tube. So when the filament, and this is the anode tube, when these electrons have to go from the cathode filament to the anode target. But unfortunately, some of the electrons might be reflected from the anode and they hit the X-ray tube, that is metal X-ray tube, or some of the electrons from the cathode might also hit the metal X-ray tube. Again, metal X-ray tube can also produce X-rays. So the X-rays which are produced in this manner from the off-focus electrons are called as off-focus radiation. So the off-focus electrons will interact with the metal surface and it again produces X-rays. And these X-rays are called as off-focus radiation. So these off-focus radiation and off-focus electrons. So one important thing for this metal is that this metal is grounded. Okay, when the metal is grounded, so these electrons which are here, few of those electrons will reach the ground or they are neutralized by the ground. So this ceramic or metal X-ray tube will decrease the off-focus electrons and thus decrease the off-focus radiation, because this ceramic or metal X-ray tube will send some of these electrons, and these electrons are actually neutralized by the ground or neutralized by the earth. Then second helpful work done by the ceramic or metal X-ray tube is it increases the tube half-life. So if you remember, in the metal, when we use the glass electrode, when we use the glass X-ray tube, we have learned that this is the anode, this is the cathode. So slowly, when the cathode is heated, when this tungsten cathode is heated, this tungsten may vaporize, okay, and it might be coated onto the glass surface. When tungsten is coated onto the glass surface, the glass might crack, and thus it will have less tube life. Okay, so in case of ceramic or metal X-ray tube, the same happens. That is, when the filament is heated and when electrons are targeted onto the anode, in either cases, when cathode or anode is heated, tungsten might get vaporized and it might coat the X-ray tube. Obviously, this is metal, and this tungsten is also metal, and there is grounding is also seen. So because of that, there won't be much effect on the ceramic or metal X-ray tube when compared to the glass X-ray tube. So as a result, the deposition of tungsten on the metal, and because the metal is connected to the ground, it will not alter the working of the ceramic or metal X-ray tube. So thus it has a longer half tube life. Then the third important thing is higher tube loading. See, the anode disk is very big. Because of this massive anode disk of around 2000 grams, the tube loading, it can acquire more tube loading. So higher tube currents can be sought. So because it is a massive metal anode, the metal anode which we are seeing is very massive, that is around 2000 grams. So it can withstand higher tube currents. So because it can withstand higher tube currents, there is high heat storage capacity of anode. So as a result, and also the transfer of heat from the metal X-ray tube to the oil is more when compared to the glass. See, this is metal X-ray tube which is placed in a metal or lead housing. So this full thing between the metal X-ray tube and the lead housing, there is oil. Okay, obviously this is metal. Metal to oil, the transfer of heat from the metal X-ray tube to oil is easier and efficient when compared to the glass. So as a result, because of the better cooling system, there is more rapid exposure and thus there is higher tube loading. So these are the important points about the ceramic or metal X-ray tubes. Thank you.